So, a right triangle is a triangle with legs meeting at exactly 90 degrees, right? So everyone draw that in your example. And when we're using the Pythagorean theorem, and a squared plus b squared is exactly equal to c squared, we know that that is going to be a right triangle. Just like the woeful construction worker, right? What about an obtuse triangle? Does anyone remember which value is greater? The hypotenuse. So that means, everyone draw this obtuse triangle. So when we're using the Pythagorean theorem, everyone should be silent, eyes up here on me. When we're using the Pythagorean theorem, we will know we have an obtuse triangle when c squared is greater than a squared plus b squared. Just like Mr. Bad. So everyone draw an obtuse triangle. And if you want to underline the Pythagorean theorem, that's good too. So, and our last type of triangle, an acute triangle, a triangle with all acute angles, right? Which value is going to be greater, the legs or the hypotenuse? The legs. That's for a right triangle. So everyone draw an acute triangle in that example box. So when we are given side lengths of a triangle, and a squared plus b squared equals c squared, everyone, what triangle do we have?
What?
A right triangle.
Right triangle. If we are given side lengths of a triangle, and a squared plus b squared, the legs are greater than the hypotenuse, what triangle are we dealing with? Legs are greater.
Acute.
Acute. If we are given sides of a triangle and the legs are less than the hypotenuse is larger than the legs. Obtuse triangle. Fantastic. So let's go through examples of this together. Turn the page over. And we are on example 1, classifying the triangle by angle measure. Okay. So, Lizzie, what are our legs in this equation? 9 and 10. So, well, first of all, step 1, everyone write the Pythagorean theorem in step 1. So under step 1, everyone write a squared plus b squared equals c squared. And then in step 2, we're going to plug in our side lengths. Just like Lizzie said, 9 squared plus 10 squared equals 20 squared. Step 3, we're going to use our calculator to find the value of the length squared. Okay? So 9 squared, 81, plus 10 squared is 100, equals 20 squared, which is 400. Everyone should be writing that down under step 3. See, everyone's got it down. Lucas got it down. Terrence has got it down. Okay, so we're going to combine like terms. 81 plus 100 is 181 equals 400. But does that equal 400? No. So we definitely don't have a right triangle. So since the value of the hypotenuse squared is greater than the legs, what's the greater angle sum? Everyone write it in step 5. So that we're going to write hypotenuse there. Because the greater side of the equation is the hypotenuse versus the legs. Right, so these legs, hypotenuse. hypotenuse for step 5. And then since the hypotenuse is greater than the value of the leg squared, what type of triangle is it again, everyone? Obtuse. Everyone write obtuse under step 6. Oh yeah, great. See, everyone has got all this written on the paper. We can move on. See, that's not too bad, right? You don't have to do any simplifying of radicals. You're just looking at which side of the equation is bigger and using that information to figure it out. All right, we're going to do one more example together. Flip to the other example. I'll know to begin when everyone's pages are flipped over. Step 1, we're going to write the Pythagorean theorem, right? So everyone do that for step 1. Step 2, we're going to plug in the known side lengths. What are our side lengths, Crystal?
8 and 7.
8 and 7. So we're going to go 8 squared plus 7 squared equals, and what's our hypotenuse?
10.
10. 10 squared. So we're going to find the value of our side lengths squared now. 8 squared is 64, plus 7 squared is 49, equals 10 squared, which is 100. Who can do 64 plus 49 for me?
113.
Yeah. 113. 113 equals 100, but that doesn't equal 100, so we don't have a right triangle. So, which is the greater angle sum? Is it the legs or the hypotenuse here?
The legs.
The legs. Everyone write legs for step 5. And since the legs are bigger than the hypotenuse, what type of triangle do we have? Acute. Woo! All right. Sweet. Thank you, everyone. All right. Eyes on me. Eyes on me. Silence. Okay, cool. So at your table groups, I see some people already talking each other through this. That is great. We're going to be on this guided practice page. And you're going to be doing the same thing I just did on the board, but you're going to be doing it with your table groups. I have all the steps listed for you. You just got to fill that bad boy in. Talk to your table members about what type of triangle it is. I will come around and check everyone's answers, and then you can move on to some more practice without my notes for you. And we can see if you can do it. I'm not letting this whole table move on until you got that down. So you got to hold them responsible.
You figured it out in like 10 seconds.
Oh, everything? Like all the pages?
Well, the good thing about that is you can't move on
Perfect.
until everyone's. No, you're not even finished. You just finished one. Yeah, I'm not saying about you. I think those snake bites have got to
I know. But like, you don't hurt to just realize.
I see Terrence helping out his group members. I see David helping out Lizzie. I see Octavia using notes off the board to help her out. That's a good idea. I see Carlos helping out Kiera. So since the legs are bigger, the hypotenuse. Look in your notes. We're looking at the board at least. The legs are bigger than the hypotenuse there. What type of triangle would be?
How do you get to the square root of 130?
This one's not even around. I did a calculator over here.
Who is it? I just got it. I see Brendan teaching his table mates. If you think you have all the answers and are ready to move on, put your hands to the sky and I will come give you permission to move on. Let's see. That looks all. That's going to change your. That won't pick it up. You said what? What else are you going to say?
You know what I'm
That was perfect. Perfect. You got to wait for us.
They're all in the wrong place.
Let's get everything down. I know you know how to work that. Perfect.
Along with the new community.
It's a one.
You may work on the first few problems, first 4 problems as a team, but after number 4, you are on your lonesome. Lonesome.
How do you do number 5 then? How do you do number 5 then?
Same way. Don't pick that up, Lizzie. I don't want to make you say I got unforceable swear.
I'm okay certified.
I see Evelyn using the Pythagorean theorem to solve number 1.
I mean, I can be CPS certified too. I mean, y'all are CPS certified. You work at CPS, right? Alright, CPS certified. You can be a janitor. So, what you did?
I see Nick using problem solving to figure out which type of triangles you got here. Then it's the right triangle. Then it's the right triangle. If you have questions as to what type of triangle you're dealing with, you can always use the front page of your notes.
Evelyn's a third. Oh, I set that up.
Let's see the multiplied by each other, so 2 squared and 2.
Oh, yeah.
16 squared. Okay, 16 squared, you got a square. That's 62.
That doesn't work. Wait. It doesn't.
All right, in 3 minutes, we're going to transition to silent independent practice. So if you have questions for your team, make sure you ask them. What's up, Kristen?
Hello.
Oh.
So we'll split it up.
What's this? Well, if you set this up like this, so you don't have to figure out this image first, because when you square it, you're gonna get a different.
At this point, we are transitioning into independent silent practice. If you have a question, you may silently ask a partner or raise your hand, but we're going to be having a silent workspace without tapping.
You know, this one is right. It's gonna be 2 squares. We have 2 squares, so 2 squares. So we have 4 times. So we take it 2 squares or 2 squares.
That's like square squares. Square.
2 times 2.
Oh, yeah. So, I know, I said you can't chat at the table.
I have not even talked to him.
You've already gotten all these right.
How do I do this? I was thinking how.
Yeah.
How you do this?
Say that, right here.
I didn't teach you a fun thing. We have 2 different
Yeah, that's how
But the 23rd.
So this is a 2 times 7. Right.
Okay, I've heard
Our own ATV.
Remember that we did that yesterday? We just showed the text,
Careful. 14 is not 1. Yeah.
She said enter, and she said shift.
Hey, this should be silent practice.
No, I did the right thing from the
The
beginning.
noise level is a little too high.
You don't have to, so this is not a simplified. That's what, so when let's say, think about distribute, she wasn't saying like find this. But even the fact that she 14, are any of those perfect squares? Yeah, so they can't simplify any more than they already are.
Square root of 61 is 60.
But you're not simplifying.
61 times
You're distributing. So this is like, so she says like 26. It's a only distributing factors, right? So how many twos?
61.
Alright, so let's put down 2 times 7. Like we're gonna break this whole thing out. Now, how many square root of 14 should it be? Alright, so do that as well. Okay, 2 times 7, not even a joke, right? 4, right? So square root of 14 14 times square root of 14 equals what?
Yeah, I was like, hey, I got somebody call me this.
Now this was 2 times square root of 14. Now it's 4 times. So different. Not even straight problems. Where? I'm gonna have to right now. I mean, you can. I mean, you can go. Well, right now, what you could do though is you can be sparing all this stuff. That's your biggest side, right? That's
What? Wash it.
because the biggest angle is going to go to the hypotenuse.
Sounds like a laundry man.
Yeah, so wherever you see the biggest angle, that's where you need the biggest side.
Oh, that's what I'm saying. In Texas.
Tell them about Texas.
Trust it, you got it. You got 257 and you have 14 are different places. Oh, no, you got it. No, you got it.
Okay, so 14.
So what your calculator is doing is radical is
I
radical.
take bacon.
So remember how you
Right,
did this
and
one?
then you're
Yeah.
Right, and those clearing it.
Eggs.
And stuff.
Pretty good. I don't know.
I mean, your work is right,
So
but
you can just tell you how many of this you have. Right? That's good.
that's
Another 31, right? Remember when we had this issue? We had
Did I do this right?
14, right?
I need you to start working on this.
Right, so all this strength, all this pattern, all this stuff.
Because I got help, I don't know.
Exactly.
Okay, so you have
Now let's see.
all these backwards processes that walk you step by step how to do it. Start looking at those.
And then again,
Right time. See? That's the only one that actually doesn't look
I
like
was talking to you, but I guess she understands me. But these ones that are looking good.
So,